So
Great. Hello, everyone, as you come in. Welcome.
我 start falando de ano.
All right, I'm gonna, if you're coming in and you're making noise, I'm gonna mute you. If you can make sure if you're muted as you come in, that would be perfect. We would appreciate that a lot. Right, we'll wait for folks to make their way in here. And we are so glad that you're here. Right. Oh, more people are entering unmuted than I thought. We might.
oh, did I forget to set that?
Maybe.
Yeah, you can just mute everybody.
Yeah, let's do that.
Mute all.
Yeah. Perfect. Thank you so much. Well, welcome everyone. We are so glad you're here. My name is Julia Silgi, and I am one of the organizers here of this group, together with Andrew, and I think Daniel's around here somewhere. So we're so glad that you're here. And before we get started, I just want to do a couple of short announcements. You probably found us via our meetup page, but I'm going to drop a link there where you can keep track of us and what we're doing. We've got a couple of really exciting meetups scheduled over the spring. I'm really excited about them, including the one next month in April. It's near the beginning of April, so it's actually not too far from now. And it is about the one of the authors of a new book is coming to present about it, which I really like this book a lot. So the book is called Bayes' Rules! Exclamation point. And so it's a book about Bayesian analysis. And so that will be in April. So join us for that. And then this other stuff we've got going in the spring. I want to just share a little bit about us as a professional and friendly group. We are a group that is here to learn about R, and so Andrew and I will be in charge of moderating. We're really glad that we have not had problems in the past with moderation issues, but I'll just share the code of conduct. We use the R Consortium's community code of conduct here. And yeah, I just want to emphasize that we want to be open, considerate, and respectful in just as if we were in person with each other. I think that is all the announcements. I guess I just will say if we would love to have you speak to us for us if you have some topic that you're interested in or something you've learned lately. We would love to talk about having you speak for us. So if you are interested in speaking, please reach out to me or to Andrew, and we would be happy to do that. So now I am going to do a brief introduction before we get started today. So our speaker today, Josh, is a professor at the U who studies and teaches political science. Josh specifically teaches data science, programming, and stats to both grad and undergraduate students. And Josh has R packages, tutorials about like statistics and wrangling and visualization. And I think it's really interesting, Josh, how your, as your research, which focuses on like public policy and media, policing, and money, and you use big data for that. And one of the ways you do that is because of the topic of what we're doing today, is being able to gather data from the web. So our topic today, as Josh has here, is about web scraping in R. And I think that is probably why a lot of you are here. So so thank you so much, Josh, for joining us. We're really excited about what you have to share.
Yeah, well, thank you for having me again. This is an awesome group to speak to. Just a quick introduction on what we're going to do and where we're going to go with this today. So web scraping, as in most kind of complex coding tasks, is not something you can just learn from watching an hour seminar. It's something you have to do a lot of practice. You have to get a lot of hands-on experience, but I think I can teach you some intuition, some of the kind of basic skill sets, and sort of give you some ideas of how you can use it in your own work. I'm a big proponent of finding data that you can scrape. One of my papers, my most cited paper, uses a massive data set of local TV transcripts that we scraped. The reason I like scraping for data sets, especially as an academic, is it usually means you're doing something pretty unique. And if you're doing something unique, it's probably going to be published a little bit better. So it's a great tool. It's viable for a lot of things and practical use as well that you could come up with. And so I'm really excited to talk to you guys about this. So this link to the code that's on the slide and that's in chat, you can follow along with what I'm doing if you'd like. If not, this should be pretty helpful, I think, either way. So I'm going to jump off this slide real quick and then open up RStudio, since that's what we're going to be using the rest of the day. So I'm assuming everybody here can see my RStudio instance and the website we're going to start working from.
Yeah, that looks great.
Awesome. Cool. So web scraping is both really simple and potentially extremely complicated. I love it because it's one of the more enjoyable programming tasks in terms of like problem solving and critical thinking. It's something that you can get, like you get an immediate observable from, you get an immediate product from, you get this cool data set. So what we're going to do today is first, I'm just going to walk through some very basics about like the principle behind web scraping. That's going to be really fast. We're going to go into a very concrete scraping exercise using rvest and then the OpenStates website. And then we're going to go through a more complex example using Selenium, which is a really a useful tool if you're stuck on a sort of complex scraping task. So one thing I should say about this seminar today is it's not really for beginners in R. It is if you don't have any prior scraping experience at all. That's sort of where I'm coming from, but I'm not going to spend any time talking about how R works or how the tidyverse works. That's sort of like something that you probably need to have a little baseline knowledge of to really get the best use out of this. So to get started then, we're just going to use these two packages primarily today, tidyverse and rvest. They work really, really nicely together, which is great. So I'm going to go through this just really, really, really fast basic example to show you like why scraping works the way it does. So this is what the basic format of any HTML page looks like. Any website has this sort of standard structure. You see a set of tags, HTML body. Inside that, you have different kinds of content. And what's key to understand about how HTML works is there's like a nesting structure. So what we kind of think about this in terms of is like children. So there's children within the div tag, which would be these paragraph tags or the H1 tags. So these children are really, really like that idea is really, really important for understanding how this works. So if you've ever worked with XML, XML is like a special case of HTML. And all of these things we're going to go through today also works exactly the same in XML, which is really nice if you use that data set. So this is what a basic HTML page looks like. You can see this from any website by right-clicking on the page and going to view source. This is just a really basic example. So what we're going to do first is we're going to get all of the text that's from this fake website that's inside of these div tags. So div tags in HTML are a common container for text. So what rvest does is it first reads in the HTML of a page. It can either be an HTML file or an actual URL, which we'll be doing in a minute. And then I'm going to tell it to look for a given node. And in fact, in particular, all of the div nodes. So all of the div nodes, notice that this is plural. So that's going to be all the nodes. And then I'm just going to have it grab the text within those and get rid of some of the extraneous white spacing around it. And if you see this, what we get in the console is we get some somewhat clean text. It still has some some white space. These are all, special characters for line breaks or tabs. If we wanted to, we could get rid of those pretty easily by passing this into the string squish function, and we get a nice clean data set of text. This is one of my favorite functions in string R package. Whoever came up with that name, just like a Hall of Fame function name. So you can see what this did is it just grabbed all of the text on the page that's inside of the div tags. It did not grab this text, which is text outside of div tags, because I told it to look within the div tags and then grab the text. So the reason I like this, right, is pipes. So because we're using the tidyverse, we can make this look a lot better. So what we're doing here could also be written like this in this really clumsy looking thing where we assign all these intermediate objects. Obviously, we don't want to do that. It looks bad. It's hard. Makes your code ugly. And then you get a ton of stuff in your environment. So instead of doing that, we just run this piping structure. So these 2 lines, or these 3 lines, are equivalent to these 3 lines. So that's why piping is super, super useful. And broadly, like in general, if you don't use it, I highly recommend it. It makes your code much more readable. But in this process, as we'll see going on later, it really helps your code. Okay, so now let's say I wanted to get a particular set of text. And in fact, I just want to get the text in this div. So what we see here is this div has an ID, div1. An ID is usually used for CSS or JavaScript to identify a particular part of a page. It's usually unique to a particular part of the page. Not always it's supposed to be, but it usually is. So we really like to look for IDs when we're scraping. Because the process of scraping is to try to point to the particular part of the HTML that you want and to figure out the best way to do that. So if I run this code, we're going to read the HTML. We're going to look inside this div1 ID, and then again, just grab the text. As you can see, I just get the text inside this div. Okay. So I know this is pretty abstract, but it'll be much more concrete in a second. And then next, what if I just wanted to get this text on line 8, my first heading? So what I can say is okay, look inside div1, and then nested within div1, look inside of h1. So this is that nesting idea that's really important to understand how HTML works, is we're saying, look within a child of div1, which is this h1. And you can see we run this and we get that text. Easy enough. Finally, we can also use other things to look at particular divs. So if you note, this div2 has some text too, but it has these 2 span tags. So span tags are another sort of container that's used in HTML. But what we can see about these span tags is they have classes. And these classes sort of identify them as particular parts of the page. And so we can reference these classes when we're scraping. So here what I'm going to say is look inside the div2 tag. And then within the div2 tag, look for span tags that have the important class. And that's what that dot signifies, is a class name. So the pound sign is an ID, and the dot is a class name. So we run this, and we get this text. Easy enough. Okay, so that's super useful. So this is the basic idea. So the basic idea for web scraping is we just need to figure out how to get what we want from a particular web page. That's our task, and that can be easy. It can be extremely hard, depending on what web page you're looking at. So I'm going to go through a pretty straightforward example today, mostly to illustrate how this works. If you've ever tried to scrape something really complicated, you know that's just really messy. So for instance, I used to try to scrape LinkedIn for a project, and LinkedIn purposefully makes it really hard to scrape their website. So you have to do a whole bunch of crazy stuff to get it to work. So today we're going to go through a more simple case, and that's using this OpenStates website. So OpenStates is a really awesome public resource where they basically track the legislative activity of state legislators in real time. So it's a super useful thing. I use it in my research a lot. There's a lot of great data on this. And what we're going to do is look at, in particular, Utah. So we're just going to go to the Utah page of OpenStates, and we're going to try to grab some stuff from this page, right? So I did just see in chat that are some web pages unscrapable? No. Every web page is scrapable. It just depends on how complex the task is. And I'll show you towards the end of this how you can sort of get around the quote unquote unscrapable web pages. But yes, some developers really do intentionally try to make it hard to scrape them, but that doesn't mean it's impossible. Okay, so we can see this Utah legislature website on OpenStates. And let's say we want to grab just some stuff off of this, right? You could think maybe we want to grab this so we can get an updated sense of what's going on in the state legislature in real time, et cetera. And yeah, there is somebody writing on the screen. So that's I would definitely appreciate if we could stop that. It's a little distracting. So what you can see here is we want to get, for instance, the partisan breakdown of the chambers. And you can see on this website that we get the number of senators and representatives, and then within that, how many of them are Republicans and Democrats. So this is a particular part of this web page, and we want to scrape it. So here's the real pro tip in scraping is on pretty much any web browser, you right click on the part of the page you want, and you go to inspect. This is really the game changer in web scraping that made this whole process a lot easier because it tells you exactly where to look in the HTML for what you want. So if I do that, I go to right click on the senators thing and go to inspect. I can see a lot of interesting information about where this content is on the web page, and in particular in the HTML. Right. And what's really nice is you can also see that when I move over the HTML, it highlights different parts of the page. This saves us a lot of time and effort. So what we can see here is we can see that both of these, the senators and the representatives totals, are nested within the state overview chambers div. So this is a div with a class. So you can see this class. And there's another one nested within it. So class names are not unique. So what we're going to grab from here, though, is we're going to grab the text. Because here we're just going to say we're naively interested in all of the text. So what I'm going to do is I'm going to read the HTML of this website and look at a particular div, grab the text, get rid of some white space. And you can see that we get all of these numbers. Okay, so this is useful, but it's not, we still have to do a lot to this text to parse it into something that's perhaps readable or something we would put into a data set, right? So let's zero in and grab particular parts of this text through the scraping process so we don't have to clean it after the fact. Okay, so now let's say we just want to grab the Senate, the total number of senators, and the partisan breakdown. So if we inspect that, we can say, okay, so this falls within this state overview chambers div with this class, but within that, there are two other divs. There's this one and this one. So we can use this really useful thing called nth child, because again, remember, you can say that you can select certain divs or certain things that are embedded within text based on the relationship as children, essentially. I'm going to turn off the annotation. There we go. Thanks, Andrew. Not what I wanted. Okay. Okay, hopefully that will stop. I don't know how to get rid of the ones that are already there. We're just going to leave that. Okay. So what we can do then is we can say, look within this state overview chambers div, and then within that, nested within that, grab the first one. So in this case, the senators one, and get the text. So you can see what that does is it gets us the number of senators, the Republicans and Democrats. So what would happen if we change this to a 2? It would get the second div. So that's useful. I want to erase this stuff. Aha, look at that. Okay. So that is a really useful trick, right? So this way we can just tell it which specifically we want, which child nested within the other ones that we want. So now let's say I don't care about the total size of the chamber, right? That's probably not very interesting. It doesn't change, but we do care about the partisan breakdown. So we just want these two things, these two list items. And what we can do is when we inspect this, we can see that this text is wrapped within these li tags. An li tag in HTML is list item. So this is really easy. We can tell it to look specifically at the li tags nested within this div structure. So these spaces mean, again, look within the children of those tags. So there's like a hierarchical structure to this. And in this case, just grab that stuff within the li tag, clean it up. So now we have a character vector of two things. And this is super easy. Now we could think about using this as part of a data set potentially. And we've done this through scraping and not really any ex post data cleaning that might be complicated or require some messy, regular expressions, which I try to avoid at all costs because I hate regular expressions. Okay, so this is like a nice basic introduction to like how you grab a particular part of a web page, but it's not that complicated. So maybe we would just do this manually, right? Maybe we just want to type this in by hand. So now let's start to go into a more complicated practical example of something where you might want to actually automate it because it becomes too arduous or too just too difficult to do unless you have a bunch of research assistants for those of us in academia. Okay, so now let's say, right, I have a program where I just want to grab like maybe every day, and this is, I'm seeing in chat that people are talking about the ethics behind web scraping. I'm going to set that aside for right now, but that is definitely something that you should consider. So all I'm doing today is essentially just grabbing one page at a time. So I'm not particularly worried about that because I'm not putting any pressure at all on the servers. But imagine, right, you had a program that looked every day to grab the new bills that were introduced. And then maybe you wanted to grab some information about those bills that were introduced. That's a pretty common thing that we might want to do is if we're monitoring the activity of a legislature. So this page has a bill section for bills recently introduced. And let's say we want to grab all the information about these bills and then maybe like save them to a data frame, right? Because then if we save them to a data frame, we can save that as maybe a flat text file or just an R data file, or we can do whatever we want with it, right? So let's try that first. So here what we want to do is we want to scroll down this page and get these 4 bills, these ones that were in the recently introduced column or part of the page. So what we can do then is we can inspect this and we can see that this information falls within this class that's card, right? So that part right there. So since it falls within class card, we can use that information to grab this text. So let's say we just run these 4 lines, right? So looking with it on this page within the card divs that are sort of have that class card, just grab the text, get rid of some white space. So this gives us 8 different things, right? Why? Because if we scroll down, these recently passed bills are also in this class. So we don't want those. We just want these bills. So there's a few ways you could get at this, but the easiest one is just to grab all of them and then just limit the ones that we care about to the first 4, right? 1, 2, 3, 4. And these are going to be 5 through 8. So that's all this is doing, is it's saying, okay, take this character vector of bills that we just grabbed and only keep the first 4. And so we get this nice character vector of the first 4 bills and all of the information about them, right? But, this is still a little messy and maybe not super practical to work with. So maybe let's just say we want the bill numbers because we have other ways of getting at the information about the bills. So all we care about is just the number of the bill, right? These are unique identifiers for a bill in a legislature. So if I right click on that and inspect it, what we can see is that within this card class, the bill number falls within this H3 tag. So H tags are header tags in HTML. And so we can use the fact that this is within an H3 tag to specify we only want that text. We don't want the rest of the text within this div. We just want the stuff that's within this H3 tag. So we could do that, right? So we can do basically the exact same thing we did above, but now we're just specifying within the H3 tag. And you can see if we run that, we get a nice clean character vector of just the bill numbers. So that's a little bit easier to work with. So you can see that this is also labeled with a heading small class. You could also use that if you wanted. It's equivalent. There's not one way that's necessarily better than others. In general, I would say there's a lot of trial and error in web scraping because you just need to figure out the best way to point your scraping exercise at exactly the part of the page you want. And that comes from both experience and then just trial and error on a given web page. Some of them are easy, some of them are hard. In this case, it's pretty straightforward. Okay, but now let's imagine that we want to get the URL for where the bills are at, right? So if I click on this link, it takes me to a lot of cool information about the bill, who sponsored it, the different actions it's had in the legislature, right? It also takes me to this really useful thing where it links directly to the Utah website's PDF of the bill. So let's imagine you're in a setting where you want to learn something about the text of bills. Maybe you want to apply some natural language processing to it, do some different machine learning stuff, right? You want to do maybe some comparison of the bill text to bills that are written by ALEC, the special interest. This is all stuff that's been done in the political science literature. But to do that, we need to download all of the bills. We also might want to know, for instance, how much the bill text has changed from when it was introduced to when it was sort of made it through the process, right? So how much changes were implemented on the bill, either by the legislators or perhaps special interests. But to do that, we need to download all of these copies of the bill. And then we need to do that over each different version of the bills that are on this page. And so this is actually pretty easy to do. So our first step then is going to be to grab the URLs of these bills. It's a little bit different because with here, what we need is we don't want text, right? This isn't going to be, the URL is not a text feature of the website. It's something that's actually in the HTML code. And in particular, it's on this A tag. So an A tag is a hyperlink in HTML. And this attribute, this href, is the page that the link goes to. So what we want then is we want this destination. We want the content of this href attribute. So fortunately, rvest makes this really easy. So here again, we're going to look at HTML nodes. We're going to say within this h3 tag, we want the A tags, right? And then within the A tags, we don't care about the text this time. What we care about is the HTML attribute href. So this is going to actually return the attribute part of that tag. If you've ever used XML, this is a super, super useful feature of working with XML. You can also use, for instance, you can do this, for instance, to get the source of images or anything else that has an attribute within a tag. So if I just run this, what you can see is I get the URLs, right? I get all 8 of them again for these 4 plus these 4. I only care about the first 4. So I'm just going to limit that to the first 4. So now I have all 4 URLs, right? They're in reference to the domain name, openstates.org. So I'm going to save this to an object, right? So now I have an object in my workspace called URLs, which is these URLs. And again, you can see this. If I click on a bill, you can see that the URL has this structure. So this is super easy to work with, and you'll see in a second. What I do is I just paste this after openstates.org to work with it. So you can sort of maybe get a sense now of why this is really powerful. I've done a multi-layered like thing that's automated. And now imagine I had a list of all of these bill URLs. I could iterate over all of that, right? And then you'll see in a second how I download. But I do want to pause real quick just for a second and make sure there's no clarifying questions on any of these basics, right? Because this is what I'm doing here with read HTML, HTML nodes is sort of the workhorse idea behind web scraping. It's read the HTML of a page, point to a particular part of the page, and then grab some sort of content. That is almost all what we're doing in web scraping. Sometimes the hard part is figuring out where on the page you want. Sometimes the hard part is getting the HTML, which we'll talk about later. But this is all we're going to be doing is essentially these 3 steps. Oh, interesting. So there's it looks like in chat, there's a new version that's HTML elements instead of HTML nodes. I didn't know about this. I think it probably works the same. I haven't got a deprecation warning from HTML nodes. So it could be that I just have a slightly older package, but it seems to work just fine. So any other questions here? And I do want to set aside, for instance, that I don't want to completely ignore this idea of scraping websites without permission. You should definitely be attentive to what you're scraping, right? If you're just scraping a couple pages, think about that in context. That's not putting any pressure on the server. If you're scraping hundreds of thousands of things, you do need to think about that. You need to have permission, and you might just need to really slow it down. That's for a different topic. I'm not a specialist in that. I'm just teaching you how to actually do the programming part of it. So yes, so it looks like there's a lot of detailed questions. IDs, right? So I talked earlier about using IDs. So what you can see in this code is there's basically no IDs on this website. They use CSS classes to do almost all of the styling. So we can't use any IDs. But if there was an ID on this website, we could use it exactly as I did early on and say put the pound symbol in front of the ID name, and then we use that to identify where we went on the page. So we really, really like IDs in web scraping because it makes our lives easier. But in this case, right, it doesn't have classes. So that's going to be really hard to work on, is if you have to really kind of use this idea of grabbing a lot from the page and then processing it after the fact. Ideally, we don't do that. And if I had more time, I would get into how to scrape using XPath. So XPath is a really useful technique of grabbing a really particular part of a page, but it's a little bit more complicated. So I don't really have time to get into that, but I highly recommend Googling that if you do get really, really stuck, is look up scraping with XPath. But most of the time, I would say we can do something like this. Most of the time, we can use this sort of basic set of tools to get what we want. So I do have a question about how to download parts of the page, and I'm going to show you how to do that next. Okay, so again, right, what the practical usage of this is imagine we just have a bunch of different links to bills, and we actually want to download the PDFs of the bills from the Utah legislature's website, right? They're publicly available. They're meant to be downloaded. And then maybe we would want to do something, like process the text from the bills for some kind of applied reason. But the first step is downloading the bills. And you can imagine, right, there are tons of bills introduced in state legislatures every year. Let's say each version of the bill, each bill has 3 versions, right? So we're getting in the pretty big numbers that we have to do manually. And we probably don't want to do that. So I'm going to show you now is like how we could think about automating that whole process, right? Taking something that's like the bill URL, going to the bill page, collecting information about the bill, putting that into a data frame, and then downloading the bill onto your computer. So this is something that I've done a lot, and it's a really practical thing to be doing with web scraping. So first of all, what we're going to do is remember I have this URLs function or object. So what I need to do is I need to construct the URL of the page I want to scrape. So here I'm going to use paste 0 to just create that, right? So pass one of the pages into this paste function, and now I get a URL that I can pass to read HTML. Okay, so now let's say we're on a bill page, right? So that's what this URL is. So we're on a bill page, and what we want is we want to get the information from this part of the page. We want to get the link to each of these versions of the bill, and we want to know what is the version, right? Is it the introduced or the amended version, et cetera? So first of all, we want that content. So fortunately, this is also really easy. So if you're ever working with tables in HTML, rvest is really, really smart with tables. So if I inspect this table of the page, I can see that we have a table with a class of hover, and within the table, we have all of the content related to the bill, right? So we have these table rows, these table cells, and these table cells have the links. So we want to get all of that information about each bill. So we're on a given bill page, and we want to get that information. So all we're going to do is we're going to read the page of this, read the HTML of this page, look for tags with the class hover. We know that this class hover is related to a table, so we can pass that into this awesome function HTML table, which is super smart and just tries to turn the table into a data frame. And what you'll see here is it actually returns a list, right? So I'm going to do this, just run this part. Oops. And so what we get is we get a list of tables on the page. So we get the first one, which is this, and then we get the related documents one. But we only care about this first table, right? So all we're going to do is just pluck the first element of the list. Pluck is a really nice function from the per package to work with lists. And all it does is it tells you to look within a list and take something out of it. So then what we're doing then is we're looking for this table in particular. But we can't specifically identify that one necessarily. So we're going to grab all of the tables on the page. And then we know that the first one is the one we want. So we're going to save this table to a data frame. And now you'll see that you get a nice data frame. So this is a data frame object in your environment, and it has a data frame format that's easy to work with. So that's awesome. So that's why working with tables is great. But this is a pretty boring data frame. Doesn't really tell us much. Doesn't give us the URLs either. So let's do some other stuff. So we want to get the URLs, right? We want to get these links to these PDFs that we can download. And these links are going to be found within this hover table. The links are nested within cells of the table. And the link itself is within the A tag, right? So within the A tag, we want this HTML attribute. And that's exactly what we're looking at here. We want this, right? We want this full URL. So if I just run these 3 lines, you see I get all 7 URLs that match this specific construction, which is these 3 plus these 4. But again, we only care about these 3. So I'm just going to limit this to the first link through the total number of rows in this table. So I could have manually typed this in, right, as 3. But why didn't I want to do that? Because I want to iterate this over all of the bills. And if some bills have 1 version or some have 10, I want this to be flexible enough to just keep the ones that are in that table. So if there are 10 rows of this table, this will keep the first 10. If there are 4, it'll keep the first 4, etc. So that's all we're doing here. And so this is just going to return the URLs for these 3 PDFs. And yes, if I change this to pluck2, it would grab the second table of that list. Exactly. So I'm going to save this to an object. Why? So now we have a vector of URLs. And then we can just add this into our bill versions data frame. So now we're starting to get a real useful data frame where now we have the version of the bill and the link to the specific bill version itself. So that's starting to be something that we can use. Okay, but maybe we want to save each of these data frames separately, or maybe combine them into a larger data frame with specifics about the bill and then the links, right? So we can reference that later. So let's get the number of the bill. We can do that from the top of the page here. So if I inspect the bill number, we can see that this falls within this class overview heading. And then we can just grab that text. So look at this page, look for the overview heading class, get the text, right? So now we have an object called bill num, and we're going to add that as a column into our bill versions data frame. So now we have bill num as part of our data frame. Okay, so now I'm just going to do some basic cleaning. And in fact, what I'm going to do is I'm going to create a file name. This file name is going to be a way to reference to save the PDF of the bill on my computer, right? So all we're going to do now is this is what the file is going to be saved as on my computer when I download it. And then what we're going to do is we're going to just download all of the files and save them as a file name. So this is using map2. You could also do this through a for loop if you wanted. I just really like the per packages. So what this is doing is it's taking the data frame bill URLs, the file name, and passing this into the download file function. So it's passing the URL and the file name, which are 2 parameters required for this function, into this function, and it'll download it. And if I run this, you can now see on my computer, I have these bills downloaded. So that's super useful. Go ahead and delete these. And then since what I want to do, right, is I want to apply this to all of the URLs that I have for each bill. I'm wrapping this whole thing in a function that takes 1 parameter, the page to be scraped, right? And so to do that, I'm just going to write this line to tell me what page I finished scraping. And then I'm going to pause the scraping exercise so I don't put too many really fast demands on the server, right? So this is a pretty useful thing to do. So if you're not familiar with functional programming, this is a really nice case of it, right? So I'm going to write my own function here called download PDF. I'm going to put this into my environment. And then I'm going to use the walk function, which is another version of map. It just does it without returning an output, which applies the URLs that I had previously grabbed, right? These bill URLs. And it passes them into my download PDF function. So if I run that, you'll see that I'm scraping each of these 4 pages. and you'll see I get the PDFs of the bills on my computer. So this is something that I've done a lot, especially scraping publicly available data, particularly government data, where there's lots of links and then there's lots of individual files that I want to download. So this is super, super valuable skill set to have. And you can imagine how scalable this is, right? And this is another trick of scraping. So if we go back to the main Utah page, what you can see is we can actually get a list of all of the bills that are introduced in a given session. And this is another like sort of key lesson of web scraping, is to look at URL construction. So let's say I go to the next page of this. So what do we see up here? We see that our URL changed to have page equals 2. And that is awesome when we find that with web scraping, because then we can use that to automatically construct new URLs to navigate to. So we're going to do that exercise, because what we want to do, right, is we want to grab the URLs of all of these bills and then hypothetically process all of these URLs and download all of the PDFs onto our computer. I'm not going to run this today to do that, but you could imagine that's a task that you would want. I'm going to show you how this works over one page, but you could easily wrap this into a function and do it across all of them. So we have our URL, and what we want to get right is we know we can vary this page number, but it doesn't tell us how many pages there are. However, it tells us that we see 20 bills per page and that there are 814 bills. So we can do some extremely basic math to figure out how many pages there are, right? So what I'm going to do then is I want to grab the number of bills and divide that by 20. And that's just a scraping exercise. So we want to grab this text right here, this particular part of the page. So if I run this, you'll see I get that text. I'm looking within cell medium 9, and then within that, the P tag, which is a paragraph tag. So let's save this too, but what we only care about, right, is we care about 814 bills. So we need to get that particular part of the page. And as I said earlier, I actively avoid regular expressions at all costs. So I'm going to do a hacky way of grabbing just that number, which is getting the text, removing all all letters, getting rid of the spaces, and then just grabbing the 814. So this is a really hacky way of doing something you could probably do with an easy regular expression, but I hate regular expressions. So now I have the number of bills, 814. I know there's 20 bills per page. So I know there's 41 pages, right? And you can check this if you want by going to page equals 41. And you can see that I'm on the last page showing 814 of 814 bills. So that's pretty cool. We've automated the process to figure out how many pages there are. And then we're just going to round that to the top, right? And now what we could do is we can take these pages and just construct the URLs. So let's say I'm interested in scraping page 5. I can construct that URL, page 5. And now we can do the exact same thing we did earlier. We can just iterate over each of these pages and grab the stuff we want. I'm not going to walk through specifically how I'm grabbing these particular, this scraping exercise. You can play with this yourself, but that's all I'm doing. So now what I want to get is another data frame of bills. Oops. So now I have a data frame that is the bill title, when it was introduced, and the latest action. So that's useful. And now I want to add to that the URLs of each of the bills and save that as part of the data frame. So now you can see now I have the URL for open secrets of each bill page, and we already have the function written to go to each of these bill pages and download the PDFs. So now we have all of the pieces we would need to download all of the PDFs of these bills. We have the URL of the page, and within that page, we already know how to scrape the links to download the PDFs and download the PDFs on our computer. So that's like all of the pieces you need to do this really kind of useful iterative process. So this is really, really easy. So this is like a very standard scraping process where when we click a link, it changes something about the URL and loads new content. So many of you may have tried to scrape stuff where that is not the case. And that's a lot of websites. So with the last like 10 minutes here, I'm going to show you a sort of crash course in how you can do this. So what we're going to use now is the Selenium function, the Selenium package. And this is a really, really useful tool. So I'm going to load up the Selenium package. And what this does is it basically creates a browser instance that R controls. You can do this as part of, you can use this as Docker. I don't like using it with Docker because I like to see what's happening so I can troubleshoot. But this is what's going on here is we're going to create an instance of Firefox. You can do this with Chrome or whatever as well. I like Firefox. It's fast. So we're going to create this browser instance, and you'll see that this opened up a Firefox instance on my computer. And now we can have R control the Firefox instance, right? So this is awesome. So when somebody asked if there are impossible pages to scrape, this is how you get around that, is you have your browser being controlled by RStudio or R. And so I'm going to use this as an example, something I've used in some of my research, which is this FCC website, which you would think they would have this nice public data repository of, but of course they don't. So what you can see here then is like, imagine, so what this website is it gives you the zip code level. For each zip code, it gives you the strength of TV broadcast signals for your local TV. So if I put in my zip code here in Salt Lake City, it tells me the signal strength of all of the different TV networks in my location. So we've used this, and economists use this as like an instrument for kind of viewership of TV. But we want to get this detail, and there's no other way to get this besides typing in your zip code, hitting go, and downloading this table. Because you'll notice that my URL here does not change, right? So whatever I type in, the URL stays the same. So this content's being driven dynamically, and we want to get this, but we can't rely on manually changing the page ourselves. So here we get into Selenium. So what's nice is, so like imagine I have this, but I wanted to get this table. So this table returns a blank because this content, when it loads the HTML from this website, is not loaded. It doesn't actually have this content on it when rvest tries to read that website, because it just reads this blank page, right? It just reads this page. It doesn't read the page with the content loaded. So we need to have Selenium load the content. We need to save the HTML with Selenium, and then we can just pass it into rvest and do our typical scraping stuff. And that's what Selenium is awesome for. Selenium is really just useful for loading up the pages that we want to scrape. So let's try this out. And the way Selenium works is you literally are telling the browser to do stuff. So here I'm going to tell the browser to input a particular zip code. So here's the zip code I want. And I'm going to tell Selenium to find a particular element on the page. And what I want it to find is this text box. So if I inspect this text box, you can see it has an ID of start point. So that's helpful. We can tell it to look for this ID, look for find element using ID with the value of start point. So this is the construction, the syntax of Selenium, and this is an object-oriented function. So we just, we take this and then we say send keys to element, and the keys we want to send to the element are the zip code. So if I run this code, you can see now I have the zip code in here, right? Look at that. So that's super cool. And now what I want to do is I want it to hit go, because otherwise it won't load the content. So if I inspect the go button, I can see this has an ID, tell it to find that and click it. And it loads that up. So that's pretty cool. And then all I need to do is I need to get the HTML. And so there's this function that's built in to Selenium, which is get the source of the page that you loaded in the browser. So now I have the HTML, and now it's just a simple scraping exercise. I've got the HTML that was generated by this, And then it's just identifying the part of the page that we want to scrape in the same way as identifying the other stuff that we did earlier. And here we want to get this table, and you can see this table has this class, and it's an HTML table. So then we get a table. It requires some cleaning, but it has all the information that we want in it, right? So it tells us the call sign, the network, the channel number, and it'll get the signal strength as well. So this is great. So now we figured out how to do this for one zip code, but how do we iterate over all of them? So I've done this before, iterating over literally every zip code in the US, which is a lot. It took multiple days to run, but it works. And it's the only really way you can do this. Otherwise, you literally have to have somebody sit there manually typing each zip code and submit. So that's kind of interesting, right? So if I type in a new zip code and just pass that into this, you can see what it does. It just adds it to the existing one, which is obviously not a real zip code. So that's not going to work. So what we're going to do is we're going to use this function in Selenium, which is just called clear element. So in this case, it's going to delete all of the stuff from that text box. So now we have a nice clean text box. So we can just do the exact same process we did last time. But let's say we accidentally submit a bad zip code to this. Like something doesn't work, it doesn't clear, or we just have a bad zip code in our data that we passed to it. So let's try it out and see what happens. So I'm going to use this fake zip code. I'm going to pass it into this text box, and then I'm going to click go. Let's see what happens. So I get a JavaScript error, right? Fortunately, we can deal with that in Selenium. It doesn't break our process. So I get an alert. And what I want to do is, like, imagine I'm not sure if there's an alert or not. I want it to figure out if there's an alert. And so I'm going to use try. So now I have a check if there's an alert. And in this case, yes. So if I can use the class of this to say if the alert window is present, I want it to do the following. So essentially check for this window. If it's present, return a blank data frame, because I want to move on to the next zip code. I don't want to break my entire iterative scraping thing that could be running for hours. I just want to skip it, move on, maybe note that it was missing so I can check it later. So that's all we're doing here. And you can see that then I can clear their alert, so I can accept it. And then I can clear the text box and then move on to the next zip code. And you can see that I wrote this into an if else, because this is something that you would put in a broader function where you want to do this error checking, right? You want to see if it's a good zip code or a bad one. And if it's a bad one, do something. If it's a good one, do something else. And then move on to the next. So that's the general procedure. So I'm pretty much going to wrap up here, but what I have here that I'm not going to run is an example of how I've used this in practice. And this is how I literally iterated over, I think it's something like 41,000 zip codes, and had it type it in, hit go, scrape the data, save it to my computer. So I literally just had it have a function that runs through all of the zip codes, scrapes them, does some error checking, does some data cleaning, and then returns a data frame that I can then save and work with and do whatever I want with. And now I have a massive data frame where it's every zip code in the country, every local television channel it can receive, and the signal strength of those local television channels. So that's a really useful data set that we can use in papers and people have used in academic papers. So that's a kind of use case for Selenium. It's hard to kind of be general about Selenium because it entirely depends on your particular website. But the kind of process is, again, navigate to the page you want, load the data on that page you want, then download the HTML, and then iterate. And so that's the basic process. So I'm going to stop talking, and I think we've got a few minutes for questions. Julia, I don't know the best way to handle that.
Yeah, so I will, so you can ask like raise your hand, and I can unmute you to ask questions. But while folks are thinking about that, I'll go through some of the questions so that people typed in earlier. Some of the questions are a bit specific about, there's kind of questions that are specific about technical details, and then there's some questions about like, how do I know when it's okay to scrape? How do I decide this? So let's start with one that's a little more on the technical side, that asked about like when you're do you ever get into some kind of a loop where you're saying download this thing and you are having a problem? So this was when you were talking about downloading the like finding a URL and then downloading it. Is that something you have a problem with? Are there particular ways to protect against that?
So yeah, so like I guess, is it the question that if you find a bad URL or something and you get stuck in that part of the iteration?
I think they were concerned about not a bad URL, but like you were finding a URL, building a URL, and then calling it, and then like finding a URL there, and then calling that.
Yeah,
like when you were downloading PDFs.
Yeah, so I mean, there's you can sort of nest this however you want, right? You can go like multi-layers deep on each page, generating increasingly more URLs. It totally depends on your exercise. So a good one to test your scraping skills on is Open Secrets. Open Secrets has a bunch of other publicly available data that's sort of nested like that. So yeah, it just entirely depends, right? And if you're ever in a situation where you just don't want your iterative scraping thing to stop if there's an error, then just build in error catching, right? So the try catch function is super helpful for that. You can check if what's returned is an error. And if it's an error, safely deal with it and then move on to the next one. There's not really a good best practice there besides trial and error, right?
Yep.
It really is. It's sort of like manually do the thing that you want and then try to build that into your code is sort of the way I think about it.
Yeah. So there was a question about dealing specifically with websites that require authentication. Like when you want to make the HTTP call and it's actually one that, so have you ever done that or?
Yeah. So so this is a common question is, so you have a login and then you need to log in before you can do anything. So guess what? If you have RStudio open browser with Selenium, you can type in the website you want to log into, log in, and then have Selenium automate the rest of the process. Of course, I'm assuming you all have permission to do this. I'm not suggesting you should do something like this without permission. If you have permission, right? Imagine and I've been in this setting before where we bought access to a website. And then because we bought access to a website, they were like, you can do whatever you want. So we were like, okay, cool, let's scrape all of it. So we paid for the subscription. And because we had paid for the subscription, they were cool with us scraping it. And that's what we did. But we had to log in. So that's a very common thing. And Selenium is really the best solution to that. It's the only one that I've gotten to work reliably.
Yeah. All right. So let's do one more technical question and then let's move up a little bit to more like, how do you decide what you can do here? So a couple of people mentioned they've had trouble installing RSelenium. Do you have best practices or recommendations of where to look or any hard-won knowledge about the installation issues around Selenium?
So I will say a couple of things. Selenium is a bit weird. You need to have Java installed. If you have problems getting Selenium to work.
No, not Java.
Yeah, you have to Google just a lot of Stack Overflow. So it's complicated. Like I don't have a good solution to that besides just trying a bunch of stuff. I will say again, like they recommend you use Docker with Selenium. I have never successfully gotten that to work. I might not be smart enough to run stuff off of command line, but I haven't been able to get it to work. That's why I use the browser one. So it's sort of, Wild West. When I was first learning this, I didn't find many resources on Selenium, which is really why I wrote a package or a tutorial on it. So there's a tutorial that basically goes over this on my website, but there's just not a ton of easy user-friendly stuff on Selenium, unfortunately.
Yeah. Okay. Awesome. All right. So let's look at let's talk a little bit about more the considerations that go into scraping. So you're a researcher, right? And a lot of people I think who are here have different roles, right? Like some are students, some are researchers, some are thinking about personal projects, some are people who work at companies, and so what when you, for example, talk to students about scraping or you think about your own scraping, what are some of the most important things that you consider about scraping as a way to get data?
Yeah, I mean, so I think this is a common practice among a lot of programmers. It's like if I could do something with programming instead of manually, I will do it. So a lot of times stuff that I end up scraping, I probably could have done by hand with how long it took me to figure it out. But I like the programming challenge. So, it is worth thinking through the trade-offs and the opportunity cost of how complicated it is to set something up. So something that we didn't have time to talk about today that I could definitely talk about in the future is working with APIs and, for instance, JSON data, which is awesome. If you get access to an API with JSON data, which is also, by the way, not always free, it's much easier to work with. You still have to do some of the same basic principles of scraping, like construct URLs, but the data is already really clean. But that's a whole different topic, and I've done a lot with that. There's another like sort of pro tip where you can actually typically find the backend API that websites pull their data from, even if they don't make it public, because it's all it's there. It's you're not like hacking. It's just they don't advertise it.
Yeah.
So that's another thing you can do.
Yeah.
But yeah, I don't know. It just depends, right? I mean, like, so a lot of times government data is the best stuff to scrape because it's publicly available. They have it in some sort of database, but they don't have it in any way that you can easily download it. And it's usually massive. So I've got stuff where I'm going to work on scraping, data from CMS and a bunch of agencies. There's just lots of it out there.
Yeah, awesome. Yeah, one thing I saw a couple people being like, how do I know? Should I assume it's not allowed or whatever? So there is I know Sharon linked to this earlier, but this is a really great package. It's called Polite. So it gives you kind of some ways to make sure that you're scraping politely. But also if you want to look, the author of that package has a talk from Usar like 2 years ago or something like that, where he goes through and he does explain like, hey, have you never heard of this before? Here's what it is. Here are some things to consider. And like an important thing is to look at, like, one thing I always like have top of mind is like robots.txt. So you look at the robots.txt of a website and that tells you if you are doing something they let you do or not. And yeah, and just the other thing I want to highlight again is that like when it comes to like the law, there has been a real, like, it is clear that like doing something for research purposes is different than doing it for commercial purposes. So that's something to keep in mind.
Yeah, yeah. And again, I'm not a lawyer, but my understanding is, it's the courts have actually decided that it's not illegal.
Right.
And so, but the stuff that I scrape that's big data is stuff that we have permission or there's no prohibitions about scraping. So either we paid for access to a website or there's just nothing on the website that says you can't. But yeah, I'm not suggesting you do something unethical. It's just that I am not a lawyer. So
yeah. I saw one person who had raised their hand and I think they put it down. Did they have to leave? Do you want to raise your hand again if you had it up? That person may have had to leave. Okay, so I know we're at time. Oh, there's Samreed. Yes, it was you. So do you want to unmute and ask your question?
Yes, hello. Is it audible?
Yes,
Yeah.
We can hear you.
So my question is about how to how to scrape the page if the page is dynamic. So in the sense that the page is loaded after scrolling down a bit.
Yeah. So what dynamic pages are exactly what I just showed you with the FCC example, right? So that's dynamic content. It's content that's loaded after user action. So you could imagine content that's loaded by scrolling down a page. So LinkedIn at least used to be like that. And in which case you can tell Selenium to scroll down a page. You can tell Selenium to click on something in particular to load more content. So it's literally your task is to tell Selenium to load the content. And however you need to do that is, depending on the website, but you can literally have, there's a thing that says scroll down a page. There's a function in Selenium that does that. So it's all figuring out the exact verbiage to use with Selenium and how it interacts with what the page is structured as.
Yeah.
Okay.
Great. Thank you
Thank
so
you.
much. All right. So I know we're just past time. So I want to say thank you so much for that really great talk, for the preparation and getting it ready. And thank you to everyone who came. I'll be able to just hang out on a little bit if anyone has any more questions for us or for me. But thank you again so much for everyone for coming. We will hope to see you next month when we talk about Bayes, how much Bayes rules. So I'll hope to see you then.
Thanks, everybody. I'll stick around for a few more minutes too.
Awesome. Thanks, Josh. Great. Anybody